All right, we're covering chapter 10, section 1. This is on circles. This is a lot of information. Definitely a lot of vocabulary, so please keep up with the vocabulary. Most likely on your upcoming quiz after spring break, you will have like a vocabulary section on that quiz. So looking at these, we're doing circles. We're learning parts of circles. These are the vocabulary words you have to know for this chapter. Circle, center of a circle. Looking at it, a circle is a set of all points that are from the distance, that are the same distance from the center of the point. So this circle is called circle A. There's my center, and what makes up a circle is all the points around. Looking at the next one, I have a radius. Your radius is the line segment from the center to the point, to a point on the circle. So what does that mean? It's right here. It's from the center to the side. So this is considered AB is my radius. Please don't get radius and diameter mixed up. That's one that normally most people get mixed up. Radius is from the center to the side. Diameter is all the way across and it goes through the center. So don't get those two mixed up. A chord, a line segment whose end points are on the circle. So it stops. It's not continuing. It's going from one end of a circle to the other end of a circle. Okay? And then diameter. Diameter is a chord. It's a chord. Again, it goes from one end to the other. That passes through the center of the circle. So it goes all the way across. All the way across. So this is EF, and this one was CD. All right, the difference between radius and diameter. Again, radius goes halfway. Diameter goes all the way across. All right, secant line. Looking at secant line, it's a line that intersects the circle twice. All right, don't forget the difference between a line and a segment. Your line goes straight through, so it's GH with the arrows. Don't get chord and secant line mixed up. They're very similar. Chord has the end points. Secant line goes straight through, all the way through. Chord just stops at your two endpoints. All right, tangent line and point of tangency. Tangent line is a line that touches the circle once. So I'm going to highlight it just so you can see the difference. Tangent line is the line that touches the circle once, so at point I. Point of tangency is the point, it's just the point. So for this, I would have IJ. Okay, that is my tangent line. And then point of tangency will be point I. All right, arc. Arc is a piece of the circumference. Okay, arc is a piece of the circumference, and you have to know the difference if it's a minor arc, a major arc, or a semicircle. So I'm going to go ahead and write that in. What these are, a minor arc is less than 180. Major arc is more than 180. And then a semicircle is exactly 180. So looking at this, if I wanted to label what arc is in bold, that is my minor arc. And when you're writing arcs, it has to have an arc on the top. So for those of you who are used to writing line KL, this is incorrect for your arc. It has to have an arc on the top. And then my last thing is my sector. Sector is a piece of the area of the circle, and this one will be called sector ONP. All right, looking at this, these are kind of showing you what everything is. So a chord, remember, a chord has the endpoints. It stops right here. Diameter goes all the way through the center from one side to the other. And just so you remember, half of this is your radius. You have your secant line that goes straight through, and then your tangent line that only touches the circle at one point, where that one point is called your point of tangency. All right, for this slide, we're going to go ahead and name some information, so please pay attention to how we're naming it and what you're looking for. Point O is the center of the circle. Name each figure. So looking at it, I have OM. Who could tell me, what is OM considered? Radius. Good, that's my radius. They're not asking me to find the values, they're just asking me to name what it is. All right, looking at the next one, they're both MN, but look at what's on top. What does the one that's a line mean? If it's just a line with no arrows, what is that? Good, that's a segment, and the one with the arrows is a? Good, so it's continuing. So if I'm looking at segment MN, so looking at my circle, segment MN is considered what? Good, that's a chord. And then what about line MN? What is it? What is it? It's a secant, okay? It goes straight through. It enters the circle twice. It touches the circle twice. Secant. All right, what about MQ? What's MQ? That's my diameter. Also considered a chord. And then again, same thing as before, look at ML. Look at what's on top of it. What's segment ML? Tangent segment. And then what about ML? It's just tangent. Yep, just tangent. And then what's point M? Specifically just the point. What is that point? Good. Point of tangency. Any questions on these? Okay, I believe I want to say on your quiz that you guys are going to get, I'll probably give you something like this where you're just going to have to name what they are. Okay, that's considered like vocabulary. All right, looking at this one. Common internal versus common external tangent lines. It says draw a segment connecting the center of the circle. If the segment intersects the common tangent, then the tangent is internal. If it does not, then the tangent is external. So what you have to do for this one is draw your little center of the circle and draw a line through it. And then we need to determine, is it internal or external? So looking at it, the first one, is this a common internal tangent or is it a common external tangent? Okay, so let's read it again. If the segment intersects the tangent, the common tangent, then the tangent is internal. Does it intersect the common tangent? No. So just showing you, I'm putting a little dot here. This is my common tangent. Okay, this is my common tangent. Looking at it, does it intersect? No, so this is called a common, is it internal or external? External tangent. Looking at the next one, is this a common internal or external? Good, common internal. tangent. Okay, how is it a common internal? It intersects the line. Okay, it intersects the line crossing the center of the circles. So just make sure you understand the difference. What are we finding here? Because there's a lot of writing. This is common external. This one's common internal, and you could tell by the intersection. Okay, think of internal as it's on the inside of the circles. Okay, it's going through the inside. It's going to cross that line on the inside of the circles. All right, congruent and concentric circles. Congruent circles, circles that have congruent radii. Okay, radii is plural for radius. So that means the radius is going to be the same measure every time. Concentric circles, circles that lie on the same plane and have the same center. So when you're looking at it, that one is talking about this image right here. Okay, it's like a bullseye. This is a concentric circle. All right, tangent circles, coplanar, what does that mean?
On the same plane.
Good, they're on the same plane. So coplanar circles that are tangent to the same line at the same point. So they're just saying these are tangent at the exact same point. The point of the circle is the same point that's touching the tangent line. So the point of tangency is the same for both circles. All right, theorem 10.1. A plane, in a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at the point of tangency. Okay, that's a lot. What does this mean? It's just saying your radius and your tangent line make a 90-degree angle. If they make a 90-degree angle, then the line is tangent. Okay, a line is tangent to a circle if and only if the line is perpendicular to the radius. So it is perpendicular. It's a tangent. It's tangent to the circle. All right, tangent segments from a common external point are congruent. What does this mean? This just means anytime you see two tangent lines where they meet at a common point, they're going to be congruent. Both of these lines are going to be congruent. So if I were to just draw another one, okay, even if it was super tiny, if I were to draw a tiny one, these are going to be congruent. Let's say I draw one here. These are going to be congruent. Anytime you see that snow cone effect, some people call it an ice cream cone. Okay, that little cone effect, your lines are going to be congruent. They're going to be the same measure. So if this was 4 over here, this one was also 4. So I'm just giving you an example with the numbers. But they are going to be congruent, and we'll see those in the examples. All right, looking at this example, I'm going to go ahead and do A in red. It says, if OR is 6 and OT is 8, then find RT. This right here, there's a tangent line and there's my radius. Is this a right triangle? Yes or no? Yes. Yes, it is. Okay, here is my right angle. How do I find RT? How would I find this? What are we going to use to solve for this? How would I find what's missing? This is a right triangle. How would I find what's missing? I don't necessarily have to use SOHCAHTOA. I can't because there's really no other angles. Good. I'm going to use my Pythagorean theorem. They're giving me my side and I just have to find a hypotenuse. All I have to do is plug it in. So I have a squared plus b squared equals c squared being my hypotenuse. And that's what I'm trying to find. I have 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. I'm going to get 100 equals c squared. Then get rid of the squared. C equals 10. All right, now looking at B. B is going to give me some different measures. So I'm just going to go ahead and redraw the triangle. And I have R, O, T. All right, they're telling me the measure of angle OTR is 45. And again, I'm still working with a right triangle. And OT is 4. What else do I know here? What do I know? What can I solve? My angle's 45. What can I use to solve this? You guys just had a test on this. Sure, I could use SOHCAHTOA, but there's something else that's a little easier. Yes. Good. This is a special right triangle. I'm going to use that 45, 90 rule. So I have A, 2 radical, A radical 2. What did I just write? A radical 2. So if A equals 4, what is RT going to equal? RT isn't going to equal 4. Good. It's going to be 4 radical 2. Always look at it. Even if it's, okay, your shapes will never be drawn to scale. So even though it doesn't look like a 45, 45, 90 triangle, if they're giving you the information and telling you it is a 45-degree angle, then you can assume that it's a special right triangle, okay? But you can't just look at it and say, oh, I think it's a 30, 60, 90. They have to give you information to tell you it's either 30, 60, 90 or a 45, 45, 90, which they did. All right, looking at example number 3, we're just naming information here. Look at it carefully, just so you're not confused. This point right here in red is E. This point right here in blue is D. So looking at it, it says, name a line tangent to circle P, but not circle O. So here's circle P, here's circle O. What's tangent to circle P, but not circle O? What line? Circle P, but not circle O. Remember what tangent is. It touches the circle at one point. William, what is it? It's a line. I need a name of a line. You need to tell me a line. Okay? What's tangent to circle P, but not circle O? You guys should be looking at it. Ava? It's not CD. Remember, tangent to circle P.
Is it AD?
What is E?
Yeah, what is E?
Where is E?
Yeah.
E's right here. I put it in the red dot.
Oh, okay.
And then D's right here. Tangent to circle P. What does it mean to be tangent?
Touch it once.
Touch it once at one point. So what's tangent to circle P, but not circle O? AD? AE? No, it's not AE. Yeah.
AD?
It's A and D aren't connected. A is not connected to D. Guys, D is this blue dot right here. So D is this line. Nope, it's not CD. It's not. ED is not a line. They're just 2 points. What is it? It's BO. Is O tangent? Is point O tangent on the circle? No, but B is. So this one is going to be line BO or OB, however you want to write it. All right, looking at the next one. So that was this one. Okay, it's tangent through P, but not O. Name the common external tangent to circle O and circle P. So key thing here is they're telling you it's external. Okay, which one's external to O and P? Yes.
CD.
Good. This one's CD. Or if you want to write DC, that's fine. And the last one for this one, internal tangent. Which one's the internal tangent? Which one's the internal tangent? AE, good. Or you could do EA. All right, I'm going to read it and then we're going to fill in information. Please pay attention to this one because this one has a lot of information. And we're going to be solving for a couple and you have to use your skills from chapter 9. So follow along. It says, circle M and circle N are tangent at P. So that means they both touch right here at point P. Next, PR and SR are tangent to circle N. What does that mean? What does PS and RS, what does that mean? Why is that important? Okay, they're touching once and they have the same vertex. So what do I know about those two lines? They're congruent. So I'm going to draw my congruency marks. Now it says circle N has the diameter, so I'm going to draw my diameter of 16. Okay, 16. And PQ is 3 and QR is 12. Let me go ahead and start filling in information that I know now. If the diameter is 16, what are my radius? What is my radii? What is my radii for circle N?
8.
What is it?
15.
It's not 15. Guys, if your diameter goes all the way across, my radius is halfway. What would my radius be? What? 8 and 8. Okay, it's going to be 8 and 8. Now, if your radius, look how I'm drawing this line, is 8. What would my radius for circle M be?
4.
Good, it's going to be 4 and 4. Okay, is anybody confused on where I'm getting these numbers so far? Okay. If I know part of PQ and QR, what does PR equal?
15.
Good, all you have to do is add them. This entire line is 15. And then what else is going to be 15? RS is also 15. Okay, so everybody should have all this information written down because you have to know how to find all these. So I think this is all the information I need. Let me go ahead and see what they're asking for. PM. What's the measure for PM?
4.
Good, we already found that. What about MQ? All right, look how I'm doing MQ. Look how I'm solving for MQ. MQ is right here. We know that this is a tangent line. It makes that 90-degree angle. So I'm going to highlight it. Look at what I'm trying to find now. This is my right triangle. I'm highlighting it. I know you could barely see it, but I'm highlighting it. This is my right triangle. I can find a missing piece of that right triangle. So what I'm going to take is I'm going to go ahead and draw that triangle right here. I have P, I have M, I have Q. It's a right triangle. I have 3, 4, and blank. How would I find that hypotenuse? What is it? Good, Pythagorean theorem, or you should know it's a Pythagorean triple, but I told you guys you didn't have to memorize that, but if you did, it's a 3, 4, 5. But let's go ahead and solve it. 3 squared plus 4 squared equals x squared. 3 squared is 9 plus 16. 9 plus 16 is 25. And square root it, so this side equals 5. All right, let's go ahead and figure out the rest. PR, what does PR equal? Good, 15. What about SR?
15.
15 as well. What about NS? NS. Good, it is 8 because this is my radius. And then NR. So again, another one that we have to find. Look at how I'm finding NR. NR is from here all the way across. I did it in that bright blue color. So again, I'm going to highlight what I have to try and find. I'm highlighting it in green. Here again is another right triangle. I'm going to go ahead and draw it. Here's my right triangle. It's a little larger this time. I have P, N, and R. We said that this is 15, and this is 8. How would I solve for NR? Pythagorean theorem. Or you should know it's a Pythagorean triple. So looking at it, squaring it, you have 8 squared plus 15 squared equals x squared. Here, I'll make it a little darker. 8 squared plus 15 squared equals x squared. Here, I'm going to rewrite it. All right, go ahead and solve it. You guys should know how to solve these. You guys just had a test on this Pythagorean theorem. All right, good. If you solved it correctly, you should have had 64 plus, what was it, 225? 289. And then you're square rooting it. X equals 17. All right, this is a lot of information on one circle. Yes, you will be given some sort of questions like this on your quiz. So you have to know how to identify information. All right, looking at this question, it says point B is a point of tangency. Find the radius of circle C. When you're given something like this, please pay attention to how you're solving this, because some people are going to mess up on this because they forgot their algebra skills. So I'm still using my Pythagorean theorem. Please pay attention to how I'm solving it. I'm still using that a squared plus b squared equals c squared. I'm plugging in what I have. Please pay attention to how I'm plugging it in. I have r squared plus 24 squared equals r plus 16 squared. This is how you're going to set it up. Please, 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 do not just distribute that squared. That is incorrect. You need to think of this question as r squared plus 24 squared equals r plus 16 in parentheses times r plus 16. So you have to do that FOIL method, or if you remember the little trick to it, then that's up to you. But do not distribute that negative 2. I'm sorry, that exponent of 2. If you do that, you are going to get it incorrect. So let's go ahead and solve it. R squared is going to stay as r squared plus 24 squared, 24 times 24 is going to give you 576 equals, now I'm going to go ahead and FOIL it if you have to. But if you don't, it's r squared plus 16r plus 16r plus 16 times 16, which is 256. This is what you should have had. Now, solving it in steps. What can I combine? I can now combine my r's. Okay, that's 16r plus 16r. What's 16r plus 16r? 32r. Bring everything else down. And what can I get rid of? What can I cancel out? My r squares are going to cancel out. I'm just going to cross them out. And then bring down what I have left over. Now what do I have to do? Good. Subtract 256. I'm then going to get 320 equals 32r. And then what do I have to do last? And what is my answer? Good. R is going to equal 10. Do I have to do this work? Yes. All right, go ahead and try and solve this one by yourself. Please write it out. All right, go ahead and check your work. Your answer should have been 10.5. Check your work. Your answer should have been 10.5. If you got it correct, awesome. If you did not, please do not forget, you are not distributing that 2. You are not doing that. This is a no if you did it that way. If you did it that way, then you forgot your 14R and your answer would have been incorrect. So please make sure you are checking your work. Go ahead and look up at the board and check your work, please. All right, last one, example number 7. It says point M and N are points of tangency. Find the value of X. What do I know when I have that cone shape? Both of these lines are going to be the same measure. So how would I represent that to solve? How would I solve this? How would I write this as an as an equation? X squared equals 9. How would I solve for this? Square root both sides. X equals 3 and you're done. Go ahead and submit your notes, please.